completed, the group variable will contain an array of arrays. I will combine this into a singular array by calling reduce. For the sake of comparison, I return back to my fetch button. I call each artist in order and then create the song list from the return results. Now I build and run. On startup, you'll notice the order in the console. The task requests are called first, and then the results are processed. Now I tap the fetch button. This time, each task is called one at a time until the previous task is complete. Async await is a nice language feature indeed. To learn more about new concurrency features, check out the Meet Async Await in Swift, as well as the Explore Structured Concurrency in Swift and Swift Concurrency Behind the Scenes. Also, keep coming back to raywinderlich.com to get a breakdown of all the up and coming iOS features. While this year's WWDC didn't provide seismic changing features like we've seen in past years, such as with SwiftUI, this year's announcements were pretty substantial. The announcements don't so much affect the code we write now, but rather it will affect the code we will write tomorrow. Yes, concurrency is the name of the game. Async await took center stage, but actors are just as important when writing safe concurrent code. One of the biggest challenges in writing concurrent code is to prevent race conditions. A race condition is when two or more threads are trying to access a shared resource. It's called a race condition because each thread is racing each other to access and or change the resource. Unfortunately, the winner may be different every time, making race conditions incredibly difficult to diagnose, never mind fix. iOS does provide a few ways to deal with race conditions. The first tool are locks. When a thread accesses an object, that thread can lock the object so no other thread can access the object until the lock is released. This can lead to situations whereby one thread owns the lock for object A while waiting to access object B, but another thread has the lock for object B and is waiting for the lock to be released for object A. Both these threads perpetually wait for each other, effectively locking up your program. This is called deadlock. Grand Central Dispatch, or GCD, provided another means of protecting shared resources by way of serial queues. With serial queues, you don't have to worry about locks. Instead, the serial queue controls access to the object's internal state. When you make a call to adjust an object, a bit of code is put on a queue and run in the order received. Each task is run one at a time. With this approach, you end up writing lots of queue-related code for dealing with your thread-safe objects, but you aren't working with locks. Still, this approach is manual and known to be error-prone, hence the need for another solution. With iOS 15, we have actors. Actors is in a lot of ways like serial queues, except you're not writing a ton of boilerplate code to manage your object's internal state. Essentially, an actor works to contain a group of related data that can be used in a concurrent system. The actor does this by isolating its data from outside callers, thereby managing its access. If you want to change an aspect of your actor must do it for you. Trying to directly change an actor's states throws a compile error, as the actor is designed to manage its own state. Actors are like traditional classes. They are reference types, have initializers. They can have methods, properties, and subscripts. They can also be extended. When defining an actor, you use the actor keyword instead of, say, a struct or a class. Let's see an example of actors in practice. Here I have a beta project open. I'm going to create a simple race condition in my code. I'm using some code written by senior instructor Audrey Tam, who not only produced a video course on concurrency, but she recently wrote an article on async await. I highly suggest you give it a read after you watch this video. First, I'll define a person class that contains both a first name and last name. Next, I create an initializer that takes in a first name and a last name. Then I defined a simple method to create a random delay. This will help produce a race condition. After which I defined a method to change the name. I add a delay to simulate a time delay for each property assignment. Now I create a name changing person set with a default name. Finally, I create an array of names. The names use the same letter, like Charlie Cheesecake. This way, you'll know I've run into a race condition. For instance, Charlie Cheesecake may instead read like Charlie Frost. Okay, now comes the fun part. In the task modifier on the text, I'm going to loop through the names and change the name of my name changing person. Next, I print out the name. Now I build and run. And in the console, you can see the names being printed out. I run it several times so you can see that my person class isn't very thread safe. It's time to incorporate actors. The first thing I do is copy and paste my person class. I change the type to an actor and give it the name actor person. Now, building the project, everything seems great. Not a single compile error. Now I create an actor person. Then I change the name of an actor person. Right away, I reach a compile error. It's telling me that calling an instance method can only be referenced from inside an actor. What gives? While actors look and act like classes, they manage their own internal state. This means method calls aren't necessarily guaranteed to happen instantaneously. Instead, actors treat method calls as messages. This means when you make a method call, that message is sent to the actor's mailbox. At some point in the future, that actor will check its mail, see a message, and respond to it. This means you'll need to await the method call, and at some point in the future, the actor will respond to your request. Back in my code, I put an await before my method call. Okay, now I want to print out the person's name. Since I'm accessing state, I use the await keyword. And that's it. I build and run. This time I get no race conditions using my actor. Mind you, this is just surface level. There are lots of things to consider when working with actors, such as working with extensions, closures, and even working with other actors. A good place to get started with actors is to check out the WWDC session video Protect Mutable State with Swift Actors. Another excellent resource is the SC306 proposal on the Swift Evolution GitHub repo. It provides a complete breakdown of the thinking behind actors. Finally, keep checking raywinderlich.com for more articles and videos on all the latest iOS features.